Yo, how are we going, team? What is up, everyone? Chat's pretty active to start off. We're looking good. It's a warm day. I've got my chilled water. I've been working hard yesterday. Day off yesterday was nice. Tina's already straight away going hard. Right, and we've got a little mini question to start off. Make sure you guys have your water. Make sure you got some paper in front of you. This is going to be an interesting concept. Mr. Murray told me to drink warm water. No, 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 no. Hell no. Yuck. Make sure you got your graphics calculator. Oh, that reminds me, I need to get my graphics calculator up. Let me do that very quickly. Hope everyone's doing well. Today could be the last stream of the holidays. But we'll see how we go today. I'm willing to do another one if it gets bad, but let's see how we go today. I'm feeling taller than normal. I guess I'll look down soon. Warm water fights off infection. Dude, I'm strong. I ate dirt as a child, so I fight off infection. I want to show you one thing very quick before we start. I'm kind of proud of this, right? This is the last 2 days worth of preparation. Okay, can you see this? Look at this, right? Notes on notes on notes on notes on notes on notes. This is only the last 2 days and nothing that I've done digitally. Right? Notes on notes on notes on notes on notes. Right? So the reason I'm showing you that is to encourage you. Oh man, I've made a mess down here. Is sort of like a weird flex, but also at the same time to be like, look, I'm putting in the work. It's my holidays too, and I would love it if you guys are putting in the work as well. Okay? Right? Now, I hope I didn't need any of these. Otherwise, I'm screwed. That one looks like a good one. Right? But yeah, if I'm doing this much work, and I'm not the one doing the exam, am I? So, I'm hoping you guys are putting in heaps of work too. Right, let's have a look. I don't need that one either. Right, so we're going to look at this idea of locus. It's going to be a bit tricky, but let's do it. Okay, 50k. Yeah, I'm also the one that could be getting double, right? Okay, let's look at this here, right? What does this mean, please? Yeah, we've got to focus on the locus. What does this mean? The length of z, the modulus of z, right? It basically means if we have some complex number, z, what is the length of z, right? Or another way we could think about it, because if we drew this, and I just said z was like out here, let's say, this is z, then this part here is the modulus of z, right? I know it's really hard to see, but just follow along with me for a second. So, you could also say is the distance from something to z. I could also define it as this: the distance from something to z. What is the something? Fill in the blank for me, please. Raman, we're done with level 1, bro. Yeah, Ryan's on it. Yeah, these are notes, but Kate, I just want you to focus for now. Write it on refill if you just need it to follow along, but just focus for a minute. I've got all the notes coming in a minute. Okay, and we've also this origin, right? I'm just going to put 0, but origin is right. Okay, so it's the distance from the origin up to z. Okay, now what if I gave you this sort of a question? Okay, if I just said, can you please draw this here? Can you please draw this? I don't need my computer there. How would you go about this? Okay, Now, I want you on a piece of paper now, not your notes or anything nicely, but just please draw what you think this will look like. And I'll draw what I think it will look like, but I want you now, even if you get it wrong, who cares, just draw what this looks like. Okay? Because if we follow what we've just written, right, where we've said, what does this mean? It means the distance from 0 to z. Well, this equation here must mean that this is the distance from 0 to z equals 2. So the distance from 0 to z, this is 0 to z, we could say that this is 2. But who drew something different to this? Who drew something different? Right. Lots of people. Yeah, some of us are already using our brains, right? Some people may have drawn this. Oopsies. Where this is 2. Like that. Or even perhaps this is minus 2. You still have a distance of 2, do you not? And some of you might have gone, well, I know that the complex number 2i has a distance of 2. And that also means minus 2i has a distance of 2. Let me just do this for a second, just to be safe. Right? So, we know all of this is true. Okay? If all of this is true, then we could say, well, any value that touches this circle will prove that equation true. Look at that nice diagram. Any value on the edge of that circle will prove this true. So let's have a think about what we've just sort of looked at. I need to just tie this up a little bit. Here we go. So this, we could call this a condition. Right? It's a condition on z. Right? The absolute value of z, or the modulus of z, must be equal to 2. Right? This condition results in what I would call a range of possibilities. This condition results in a range of possibilities. And that range of possibilities, in this example, turns into a circle. I was about to say a circus. A circle. Right? But this idea of a range of possibilities is what locus is all about. Is what the locus is all about. Does this make sense so far? Ramen is not, that I'm aware of. Aerodynamics happy, Ryan's happy, Rishi's happy. Good. Sip of water. Let's approach this from another angle. Okay? Or, actually, let's carry on with this a little bit further before we approach it from another angle. Right? Let's look at this. So, we've approached all of this graphically at the moment, haven't we? This is graphically, we're looking at this visually. But let's approach it algebraically. So let's grab this equation and put it down here. So I'm going to say, well, the modulus of z is 2. And I'm going to very quickly prove to you that this one, this one, this one, and this one is all true. And if those four are true, then that's kind of a bit more obvious that a circle is true, right? But let's look at it algebraically. Well, the first value, we've got the absolute value, oopsies. The first value over here is 2, right? So we've got the modulus of 2, or the absolute value of 2. and that equals 2. That's what we want. It meets the condition. That's the first one. Well, minus 2 is going to be the same, isn't it? What's the absolute value of minus 2? Well, that's 2 as well. And you could do it using the absolute value, but you could also do it using the modulus, right? It turns out the same. Let's prove that to you. So let's say 2i is z. So the modulus of 2i is going to be equal to the square root of 0 squared plus 2 squared, which is just going to be 2. Right? And how about minus 2i? Well, that's the square root of 0 squared plus minus 2 squared, which is just going to be 2 as well. So all 4 of these possibilities all work. So what I'm doing is I'm algebraically drawing this picture essentially, right? By doing 4 lines of algebra to prove these 4, and then we can use a bit of intuition to kind of realize that, well, you could have a circle with a radius of 2. We'll hold that true, won't it? Nice. Good. Fantastic. Now let's approach this from a slightly different angle, because I spent so long on this yesterday, just like kind of wrapping my head around it, right? And there's not heaps of stuff out there, not heaps of videos. There's no good Khan Academy video on this, which made me struggle. But I had a look at some notes. I've sort of figured this out. Another way to approach this is to think about it like this, right? Imagine I have a number. Let's say the number is 4. I want to know what numbers are 2 away from 4. What numbers are 2 away from 4? We can say 2, we can maybe write that as the 2 like that, so you're not getting too confused. Right? What numbers? Can you give me an answer? I've got a number 4. What numbers are 2 away from 4? 2 and 6, right? And we can look at this on a number line. This would be 0. This would be 4. Oopsies. Let's go 1, 2, and 1, 2. So 2 and 6 are both 2 away from 4. Right? We're happy with that. And let's look at this algebraically again. Now, I'm just going to tell you. Oopsies, not 6. That should be a 2. That this is what it should look like. Right? Because I'll prove it to you through the algebra, and then we're going to learn something from this. Right? Don't think about why just yet. Let's have a look. Right? I'm going to use my numbers 2 and 6 and see if it holds true. So what numbers? Remember what numbers? This essentially is x. What numbers? Well, 2 works and 6 works. So 2 should work in this. 2 minus 4. Is this true? Well, I'm not going to say equals. Is this true? Well, the absolute value of 2 minus 4 is minus 2, which is just 2. This holds true. And how about 6 minus 4? This is the absolute value of 2, which is 2. That holds true. So you can see that the notation here is the number that we are at is the negative version in this absolute value within the modulus. Right? So this notation here is saying to us this sentence: the distance from 4 to some number that looks gross, to some number x is 2. Right, and this is really, I really found it so difficult to wrap my head around this until I turned what we're doing into like a sentence. Right? Where we say the distance from 4 to any number, let's generalize any number by calling it x. The distance from 4 to x is 2. That's what this sentence is saying. This maths equation is saying. Right? Where we can say, essentially, this part here is saying the distance, right? The modulus of something is the distance of that thing from a certain point. This piece here is giving us the 4. Obviously, some number x is given by the, let's go here. Some number x is given by some number x here. And the condition we're trying to meet is 2, equals 2, right? Is the same as 2, equals 2, is 2. Does this make a little bit of sense? Are you with me so far? Pretty colors, I know. Yep. It's gonna be a weird thing to wrap your head around, but you've just got to trust me. Follow along the journey. Okay. There's no song skip, dude. There's no song playing. Sorry, dude. Right. Let's have a little think, because we're basically asking ourselves, like, from this is what the sentence is saying, right? Distance from 4 to some number x is 2. Then the question is, what could x be so that that sentence is true? And the answer, in this case, is 2 and 6. But is it? Haven't we spent majority of this year going into the idea that numbers don't just exist in one dimension like this? Haven't we also talked about how there's an imaginary axis as well, where the distance from 4 to some number x, we can go 2 in this direction, 2 in this direction. Surely we can go 2 in this direction, 2 in this direction, and we'll get some value of x being here and here, right? This is what we've done all year. So when we start opening up this concept to imaginary numbers, we start to realize that there's more than just these two answers here, isn't there? There's more than just 2 and 6. And in fact, there's heaps, right? Because before, when we did this, when we looked at this situation, we drew a circle, right? And in this situation, you're going to see they would have a circle, wouldn't we? You with me? So when we look at this, we could say this is the question is, instead of calling it x now, I'm going to call it z, because that's what we typically call a complex number, right? So we're saying, what is this sentence saying here? What is this math sentence saying? We'll have a read, have a look up here, and compare it to this down here. We're saying the distance from 4 to some complex number is 2. The distance from 4 to some complex number is 2. Kate's saying, why wouldn't it be negative 2? It can't be negative 2 because negative 2 over here, negative 2 on the real axis is negative 2, and the distance from 4 to negative 2 is 2, 4, 6. Right? Yeah, Mr. Raja, I'm going to write that now. Does that make sense, Kate? So this sentence, sorry, this question, what's it saying? Hey, Abhishek it off, thanks dude. If you put it in that, yeah, have a look. If you put it in the absolute value, you'd have minus 2 minus 4 makes minus 6. Absolute value minus 6, 6. So what is this sentence saying? We're saying the distance, I'll write it in blue. What could z be so that the distance from z to 4, or from 4 to z is how I like to think about it actually, but it's both the same, from 4 to z is 2. Now, we could list off a whole bunch of numbers, right? Our response to this, or our answer to this could be 2, 6, 2i. Oh, no, it's not 2i. That's, what's that? That's 4 plus 2i. 4 minus 2i. And you could do this forever. Okay, but we know that when we have a line on a graph, let me tidy this picture up a little bit, okay? Watch this. Oh, nice circle, sir. When we have a line on a graph, that how do we represent all of these possibilities? Right? How could we represent every single one of these possibilities? Right? Well, we can create an equation that states what this circle is. Right? If only there was a way to represent all of these possibilities, and it's with an equation. Right? We want to find the equation of the locus. Okay, thanks so much, dude. We've peaked above 450 followers. Thank you so much. Okay, so we know that everything along this line meets the condition. So everything along this line is a locus. Let's get the equation of the locus. Right? The equation of the locus. Now the process to do this, when the first 5 times I did it, I didn't understand why I was doing it. But I did it, and I got to the right answer every time. And I was like, wow, it's kind of cool that it works. The more I thought about it, the more I understood it. And so don't panic if you don't get it the first time, but you can do it the first time. Right? I say this in class all the time. Remember, I don't know everything about my car, but I'm a bloody good driver. I don't know everything about this, but I can do it well. So let's have a look at this equation here. Z, let me just check my notes. Let's actually, so we've done this one, right? Around 4. Let's backtrack a little bit. Remember we had this one a while ago? Okay. Let's have a look at this. So remember, what is this saying? The distance, or it's saying, what is Z? What could Z be so that the distance from something to Z is 2. What's the something here? What could z be so that the distance from something to z is 2? What's the something in this question? 4 was the other question. In this case, it's 0, right? Or the origin, you could think about it. But if you look at this, would you agree that this is the same thing? Or let's do minus. Plus or minus 0 doesn't really matter. It's the same thing. So we're saying the distance from 0 to z is always going to be 2. Now let's work through this algebraically. Obviously visually, we could see that it's going to be a circle, right? A distance of 2i minus 2i minus 2. You'll get a better drawn circle than what I can ever do. But let's look at this algebraically. Now, let's let z equal x plus iy. Now, this is the part that I struggle with the most. So let me briefly explain it, but let's just work through the algebra. Z is just an imaginary number, right? It's just going to be some imaginary number. It could be any imaginary number along this thing here. So we're just going to say, let z be a general imaginary number, x plus yi. Okay? And then we're going to substitute x plus y into everything and just follow it through. So we're going to say, well, z could be any complex number. Any complex number is in the form of z equals x plus iy. Now our equation is the modulus of z equals 2. And we've said z is x plus iy. So I can replace z with x plus yi. So far so good. Now by definition, the modulus is the square root of the real part squared plus, I don't need a bracket, the imaginary part squared. You with me? Now think back to the start of the year when we did questions with surds. How do I start solving this? Well, I could square both sides and end up with 2 squared, or 4. Right, we're actually bringing together so much of what we learnt this year on this concept. Right? And if this doesn't look familiar to you, this setup here, don't panic. But let me tell you that this is the equation of a circle. And in fact, I'll even give you the general equation of a circle, which, Mr. Maraji, correct me if I'm wrong, but you get it in on your formula sheet in your exam, maybe? Why didn't square the I? You don't do that when you do the modulus. Right, when you're doing the modulus, you're just grabbing the length of one side and the length of the other side equals the length of the other side squared. Because right angled triangles, a squared, b squared, c squared. You only ever use the coefficient. Mr. Raj is right, he's agrees. So we will get the equation of a circle. You'll get lots on your formula sheet. But let me show you a diagram. Right? I know it looks like an ugly equation, but it's actually it's one of the nicest ones. Let's look at this. I've drawn this here for you. So this equation, ignore the rest of this, but see this here. This equation, x squared plus y squared equals 2 squared, gives us a circle with a radius of 2 centered at the origin. Okay? And if you think about it, we said in the question, we said, what could z be so that the distance from, I don't fill in the blank, 0 to z is 2, right? From 0 to z is 2. Anywhere along here is what z could be so that the distance from 0 to z is 2. Right? And remember that this y-axis is actually an imaginary axis. So if I picked this number here, 1.34 plus 1. oh I missed 1.485i will have a modulus of 2. Will be 2 away from the origin. Crazy, huh? Yeah, the diameter is 4. I don't know what use is that, but we can describe it, right? So when we describe this, we could say, let's describe it, a circle centered at 0, 0 with a radius of 2. And let's have a look at this equation, this general equation, this equation here. This h and k represent the shift of this circle, right? So h is left and right shift. No, my camera. It did it again. I thought I could go for a whole stream without it doing that. Fixed. Right? So, there we go. Yeah, H represents the left and right shift, and K represents the vertical shift. But we'll look into that with a little bit more detail in a second. And R represents the radius. Are you joking? Are we just going to have to do a no? Let's try that USB port. What the heck? Can you hear it? Is it working now? Goodness gracious me. Right. Let's look back at this other question we had here, the z minus 4 one. Right? So we're going to go to here and actually like fully complete the question. Was it 2? Yeah. Again, before I even answer this question, I write out what is the question saying. I found this really helpful for me to understand this, and I encourage you to do so. Okay. If h is needed, does it shift left or right? We'll explore that right now, Tina. Right, in this question here. So, what I would love you to write this out every time at least when you're learning how to do these questions. What could z be so that the distance from z, or from 4 to z, remember if it's minus 4 in here, it becomes plus 4 here, from 4 to z is 2. What could z be so that the distance from 4 to z is 2? We could draw it. The distance from 4. Where's 4 going to be? 4 is going to be over here. And we're going to basically have a circle of radius 2. So this is going to be 6 and 2. You could see this. You'll have a circle of radius 2 centered at 4. But let's go through the algebraic way and see if we end up with that equation. So the equation should be something along the lines of x plus or minus 4. Let's figure out what that's going to be. There's no y shift, and the radius is going to be 2. So that's what we're expecting. Let's do it and hope we get there. Before, remember, the first thing we always did is say let z equal x plus iy, some imaginary number. Then we substitute it and go from there. Instead of z, we're going to write x plus iy, minus 4 is still there, and equals 2 is still there. Happy so far? Right? Now, let me show you this. Are you happy with what I've done here? Or are you happy, more importantly, why I've done this line of working? Yeah, Kate's exactly on the money, right? Group the real part. Yeah. So that means when I do the modulus of this, we're going to square root the square of the real plus the square of the imaginary. And the cool part is we don't even need to do the squaring or anything. We just get rid of the square root by squaring the other side. And look at that. We've got an equation of a circle. Where this minus 4 represents a positive 4 shift. Okay, because that's what we know the diagram should look like. So to answer your question, Tina, when we have x minus a, this is right, and or let's say minus h, x plus h is left, and I'm pretty sure the same thing happens with y, where up is down and down is up, basically, or negative is up. So far so good. So we could describe this. In fact, we could draw it. And I've drawn it here. We could draw this. And see this here. Focus, team, focus. Right, this is my number to start off with. I had 40 as my number to start out with. The number inside here. Right? This part. Then I'm saying the distance from here must always be 2. Anything along here will give us a distance of 2. Right? Anything along there. And that circle is exactly what we've drawn. And we can say that this circle is, let's answer the question of describing the locus, circle centered at 40 with a radius of 2. And we're done. Do you have to draw their circle in the exam? Honestly, it depends on the question. But it will hugely help you. In fact, sometimes you can just draw the circle and skip the algebra if you find the circle easy. Or you can just do the algebra and do it. Depends on how hard the question is, to be honest. Okay, we've got a couple questions coming in. I'm going to set you up with a question while I answer these other questions. So the next question is going to be, let's get the worksheet and have a look at it. I think it's here. Here we go. So here's some notes for you to take down if you need them. But I want you to look at this question. We've just done that and a harder one. I want you to look at this one here. Can you show the equation in graph? What do you mean 20432? I don't understand your question. Yep, this sheet is on your Google Classroom. I've just uploaded it. And it's also on your one. It's also on your one. I want you guys, I'm going to write this question down. I'm going to do one thing to it, and then I want you to try it yourself. Z minus 3 plus 2i equals 5. I'm going to do one thing to this first. Because if you do this wrong, you're just going to hate yourself. Guys, focus for a second. All I've done is I've basically made this a negative for this whole piece. Because remember, in this one here, the negative of the number is just the number. So the negative of the whole number, this is now a complex number, so this whole thing needs to be made the negative. Okay? That then means this is the number that we are getting far away from. Okay? I need to fill up my water. Can you start this question? You can start it by writing a sentence and drawing a picture, or writing a sentence and subbing in x plus yi. Here's the question. Remember the sentence. I'll fill up my water. Okay, let's have a look at this. So the sentence I want to see from you guys is, what could z be so that the distance from, and now this piece, 3 minus 2i to z is 5. No, not too fast. We've got to focus now. We could draw this as well, right? So, 3 minus 2i is going to be 3 minus 2i, like down here somewhere. And we're basically saying we always want to be 5 away. Thanks for the follow, my man. Something like this, right? It's not a very nice circle. I'll make it nicer. But you can see it's going to be a circle, right? Because we're always 5 away from a single point. Now, I don't know the equation of this circle. You could probably figure it out by using some logic. But let's do it the algebraic way, because the algebraic way we need to know how to do, even though it's harder, we need to know how to do it for harder questions, right? I will shake it off. We'll get there and we'll see if you're right or wrong. I think you're right. Yeah, makes sense. So let's have a look. Let z equal x plus iy. We're going to substitute this into here. X plus iy minus 3 plus 2i. I'm subbing it into the first one, right? But you could sub into the second one if you wanted, but the first one makes it slightly easier. Okay. Let's group the real, x minus 3, and group the imaginary, plus, and in fact, I want to do something clever. Hold on. Tell me if you're happy with this, or if you're unhappy with this. I've basically grouped the imaginary parts, but then factored out the I, because I just want the term in front of I. Okay. Now we're going to do the square root x minus 3 squared plus y plus 2 squared equals 5, which we know is going to turn into, oopsies, plus y plus 2 squared equals 25, which is 5 squared essentially, right? So we can say a circle centered at 3 and minus 2 with radius of 5. That's our answer. Or you provide that equation, or both. Why did I square? to get rid of the square root. I square both sides. Okay, so far so good. What's the time? 11:47. We've got a little bit more time. I'm happy to go for an hour. Let's look at example 2c. Can you see it there? I'm going to write it up here. Vash, that's a really good question, Mr. Maraji. So Vash's question is, would you write the coordinates as 3 minus 2 or 3 minus 2i? I've read a couple different things. I think you just write it as 3 minus 2 because they often ask you for what they call the Cartesian coordinates or the Cartesian equation, which is just on a normal Cartesian plane. Like this. This is what we call a Cartesian plane. Right? But on the Argand diagram it is kind of like that, but it's a Cartesian coordinates. That's why we've got this equation here, the x squared y squared. So Miss Maraji agrees 3 minus 2. But that's a good question. It's good thinking. Right. Please, all of you now, on the pieces of paper that you're working on, write down a sentence as to what the hell this question is saying. Because it is different, it is new. Let's convert it into something that we can read and understand. My advice would be look at the left hand side individually and the right hand side individually. Or think about it that way. I'll give you a little bit of time to do that now. Write the sentence for what this means. Or if you want to type it into chat, you can type it into chat. We've almost got 460 followers, by the way. 457. 457 people think it's reasonable enough to follow a maths Twitch page. How sick is that? It's a good sign for the world. Someone type it in chat. Hamza's lazy. So, this piece, we've already written what this means. Right? In fact, we did it with this question here. But just ignore this part, right? What could z be so that the distance from 4 to z is? And let's get rid of that. Abhishek's bang on the money. Right? This means, what could z be so that the distance from z or from 6 to z is, and normally we say is some number, but the right hand side is saying is saying basically this piece, right? But with a different number. It's saying is the distance from 2 to z. So we're essentially saying, what could z be so that the distance from z to 6 is the same as the distance from z to 2? Right? Let's draw a diagram to help us think about it. But again, I'm going to do it algebraically because my algebra is better than my drawing skills, right? So, a value of, in this thing, remember, when it's minus 6 here, we're going to plot it as positive 6 over here. When it's minus 2, we're going to plot it as 2. So the distance from z to some the distance from some number z to 2 and to 6 needs to be the same. Now think about it. If I plotted a number here, the distance from here to 2 is obviously much shorter than the distance from here to 6. And anywhere along this is going to work like that. And the same concept applies in the other direction. So we know for a fact it must lie in between 2 and 6. And if you think logically, it obviously has to be right in between 2 and 6. But that was only if we're working on one axis, which is just real numbers. But we can think about complex numbers in a much smarter way. Right? And before I don't know whether I want to give it away by drawing this, or if I want to just do the algebra. Yeah, I think Kate and Abhishek are on the right track, right? We're up and down as well. If you imagine that I had a value here, well, the distance from 2 to there and 6 to there would be the same. Same thing here, 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 here. So anything along this line would be the same distance, wouldn't it? Right? And remember, your answers are like so close to being right, but not quite right. Right? So a lot of you saying it like z equals 4, z equals 4. Right? Yes and no. Right? Z equals 4 is telling me that z must be that number and that number only. Remember, the whole point of this is that we provide a range of possibilities, which is in the form of an equation that involves x and y. Right? So let's have a think about this. If you're ever unsure, which should be always, or no, that's not kind of true. We should just always do the algebra, right? Let z equal x plus I y. X plus I y, oopsies, minus 6 equals x plus I y minus 2. Ryan is 100% right. In that case, can it be infinitely up and down on the same line of 4? 100%. That's the whole point. Right? Fat Pikachu and Not That Matt are kind of on the money here. Let's have a look at this. Let's group the real. And group the real again. And now, if we do this, I'm going a little bit faster now, and do this. That's what that modulus means, y squared. And if we squared both sides in this case, we're just going to have this anyway. Happy so far? There's y squared on both sides, so we can cancel that out. So we've got x minus 6 squared equals x minus 2 squared. Let's expand these. X squared minus 12x plus 36 equals x squared minus 4x plus 4. If we do all the cancelizations, we can see that the x squared cancel. And let's go minus 12x plus 4x equals 4 minus 36. Minus 12 plus 4x is what? Minus 8x. This would be minus 32, which means x equals 4. Right? So what is this answer telling us? Remember, this answer is giving us a range of possibilities of z that meets this condition. It's answering this question. What could z be? What could z be? Not what is z, but what could z be? Z could be anything that follows this condition. Right? Which is anything along this line. Big brain, big brain. Right? Anything along this line. And here's another way to even think about it, which is what Hannah was saying in the chat. right? You could essentially say that z, remember z equals x plus iy, right? That's the whole point. Now we've said that as long as z meets this condition of the x being 4, it doesn't really matter what y is. It will still meet the overall condition of this thing here being halfway between those two numbers. Right? So you could provide an answer like this, where you say, well, z could be 4 plus yi, where y is any number. Okay? And you can see this diagram here represents that, and you could say x equals 4, or the locus is at x equals 4, or as a line. Let's write a sentence here. The locus is the line of x equals 4. Right? I'm just going to sneeze again. There's a sneeze every stream, isn't there? Thank you so much, blessings. So, I had a couple questions like, do we need to sketch or anything? I double check with Mr. Maraji, so Mr. Maraji can answer, but I think it depends on the question. The question here was sketch the loci. So, we didn't even need to do the algebra, we could have just sketched it, right? But I wanted to do the algebra because I'm trying to get you to understand this whole concept. Right? Yeah, so Miss Brody says depends on the question as well. So it all depends on the question. Right? Let's look at example 3. Right? Let's skip this one for now. We can come back to it. I want to look at this one, because this one is kind of basically what we've already done. And he's saying do the algebra for E. Yeah, I think the algebra is more important than the diagram. I found that for the excellence questions, the diagram was really hard to draw based on the information given, but the algebra was easy to do. Okay. Yet loci can be an E for sure. So that makes it the world's easiest M, because if you get halfway through the question, you get a merit. If you let x equal iy, plug it through and get to some conclusion, you'll get it. I'll state the gradient. Yeah, so the line of x equals 4, gradient of 0. I guess, right? I think that's kind of implied by that equation. Right? Yeah. Gradient is 0. Or gradient is, yeah, undefined is better, right? And vertical line. Oh, the webcam froze again. I didn't even hear it do that time. Man, oh man. Let's do. Here we go. Now, I tried to update the drivers yesterday, dude. Webcam's not brand new, but it's really good. It's a C920 or whatever. Okay, let's try this one here, please. Right? Again, I want to do this one, and then we're oh, time's going fast. How are your brains? I want to at least do one of these. Mr. Brady is saying this is an E. Really? I think this one is easy. I'm so surprised. I genuinely thought this one was really easy. Interesting. With correct description of the locus. Is it the same as 2C? It's really similar. Okay, let's do this one, and I'll leave this one for you for homework. Okay, and a couple of these. But that hopefully we understand this pretty good. Let's do this one here. Okay. So the question is sketch the locus. So yes, we will have to draw the diagram. Represent the complex number z equals x plus yi. They've told us the let step. Given that, here's our conditions. Determine the Cartesian equation. So provide an equation and do the sketch. Right? Okay, let's do it. So example 3. Let's really focus. Z minus 1 equals z plus I. Again, what is this saying to us? Distance from 1, remember it's got to be negative. I always do this. I always make sure that we do this. I always make sure that you do this. I'll highlight it. Because it really helps with our diagram, right, and our explanation. Right, because it's always, that's the format that it is in. Right, the distance from 1 to z is the same as distance from minus I to z. Right? Now, Ryan said, isn't this basically the same as the previous question? Yes and no. Right, well, Kate's ahead. Right, I'll get there. Miraji can check it. So let's plot this very quickly. 1 would go around here, wouldn't it? And minus I would go around here, wouldn't it? So the distance is always halfway between those two. Remember, the same distance between the two. So for starters, we know that's going to be a point. And in fact, we're going to have a line like this, aren't we? Where you're always oopsies, halfway between. Now my diagram's not fantastic, but it's a good enough sketch. You're always halfway between. Oh, Kate, check you're working. Okay. Right, the first algebraic step, let z equal x plus iy. So let's do it. X plus iy minus 1 equals x plus iy plus I. Can we group the real, group the imaginary? Equals, let's group the real, group the imaginary. And factorize as well. Am I going too far? Yeah, patience is a good reminder. Me and Miraji were discussing this yesterday. Honestly, this is not a hard E, it's just a long E. So you just got to do the substitution, got to work through the question. When I did it, I used this much working. Write a whole page. Takes a long time, but you just truck it through. Right? Just follow your nose, keep working hard. So, we're going to square root this side. X minus 1 squared plus y squared. Square root this side. X squared plus y plus 1 squared. That means the square roots will cancel. X minus 1 squared plus y squared equals x squared plus y plus 1 squared. Okay? And let's just do all the expansion and see what happens. Hopefully it gets easier. X squared minus 2x plus 1 plus y squared equals x squared plus y squared plus 2y plus 1. In the root, remember when you're finding the modulus, you're just taking the front numbers, the coefficients. When you find the modulus, you don't include I. Yeah? Good. We've got this. Look at this. The x's are going to cancel. The y's are going to cancel as well. So let's make it look like this. Right? And I should look at this step to here And I should probably refer to my diagram too, because my diagram is a straight line, right? It's a straight line, it's a negative gradient, I can see that. Straight line, negative gradient, and at the moment it's going for a 0, but it was just a sketch, so I'm not really sure. Right? By eliminating the x squareds and the y squareds, we've made that conclusion, right? It's a straight line graph because we've only got x and y. And the number in front of x so far is negative. Let's hope it stays negative because we want it to be negative, right? So we want it in the form of y equals mx plus c. We can do this, minus 2x, the 1's cancel as well, equals 2y, divided by 2, minus x equals y. So our equation is this. So the question was, sketch the locus, which we did, determine the Cartesian equation, and we should describe it too, which is what Mr. Maraji has done in the chat. So let's use his description here. The line y equals minus x is the perpendicular bisector of the line joining 0 minus 1 and 1 and 0. Right? Bisector means cut in half. Right? I'll show you what this means. I'll graph it bigger. This is 1, 0. Minus 1, 0. Oopsies. 0 minus 1. If you imagine, well, let's not even imagine. Let's just do. If you saw a line like this, okay, the perpendicular bisector is the line that cuts at 90 degrees. Ugh, I want it to go through there. At the halfway point. Halfway. Okay. Right. Oh, Miss Marty says add a little bit more. Okay. With gradient of minus 1 and x-intercept of, what's the x-intercept? 0. I just scrolled all the way up randomly. Of 0 and y-intercept of 0, right? X and y intercept of 0. Okay. Easy E. So 8 points for an E, sir. I thought it was 8 for 2. The intercept came from the diagram. Here. It also comes from the equation, right? Remember the equation was y equals minus x. If I want to find the y-intercept, 0 equals minus x, well then 0 must equal 0. So x must be 0. Wait, Miss Modi's saying there's only one E question. This is news to me. I've told my class that although I can teach calculus, I don't know much about the exam. Does 90 degrees in the middle mean anything later on? Well, I just want you to understand that concept, that it's I mean, it has to cut at 90 degrees. It's just that, okay, this sentence is a complicated way to explain the phenomenon that we all agreed on when we were doing this diagram, right? That firstly, the first point you need to think about is halfway between those two, right? Halfway between these two, that's the bisector, right? But the perpendicular bisector is the whole line that is perpendicular. What's done with the 2 outside the z? Daishokusai, that's for you to think about. No, Matt, I'm not sure. So Matt said, what points do you get if you get the description wrong? I'm not 100% sure. I haven't looked at the marking schedule or anything like that. I didn't even realize we had to put this big description here. If it said describe the geometry or whatever, then yeah. Is there a model description? You're looking at it. It's on the screen. Yeah, Kate's right. When someone said, Daishokusai, don't do what you just did there. So he said 2 times z minus 6i. 2z minus 6i. Don't do it like that. Do it exactly the same as what we've been doing. And put 2 on. Oh yeah, I should extend. Sorry. I had to do that so that it was straight. There we go. So for description, you need gradient, x and y intercepts. Yes. So that's for straight lines. For circles, you need the center and the radius. Okay. Right, how did we find that, team? Are we feeling okay? I felt like that actually went quite well. I like the circle better. Yeah, fair enough. Good. I think locus is the thing that students tend to not quite get the first time round. You guys are lucky, man. I was like so intimidated when I looked at this yesterday. I was like looking at it, I was like, oh man, this is scary. I couldn't find any good videos. I found a couple good ones. Easy to mess up the algebra, I agree. One of the mistakes I made a couple times was this very first thing here. Making sure that I made that negative. Right? But that's only to help us draw the diagram. Easy money. Easy money, but easy to lose. Okay. You just make that negative to help you draw the picture. But when you do the substitution, just do it straight into there. And exactly what Marjorie's saying. That's why you need patience. Because look how much working that took. 2 pages. A lot of talking, a lot of sentences. Right? And I've not seen anywhere else in any notes this explanation that I've made up. Okay? As clear as that. Right? The distance from the number we've been given to z is the same as whatever's on the right hand side. Yeah, Benson theorem number, we're up to number 3 or something now, right? Shut up, Krish. Okay. I think we're done there, right? I don't think we should go any further. We've worked for solid for like an hour 15. Can you please challenge yourself to do this one? And then for revision, just tackle. I mean, I don't expect you to do all of these, but tackle a couple of them, especially the hard-looking ones. This one looks kind of interesting. This one looks kind of interesting. This one looks kind of interesting. Try those out. And you can often, as long as you can plot these on a graph, once you know your, like this is what I did on Desmos, right? Like, let's say, look at this. I put my first value. Sorry, I put my two values. And then I plotted this and say, oh yeah, it must be fine. Right? In fact, let's do this one here very quickly. So the coordinates are basically 0 minus 1. Let's turn all these off. And 1 and 0. Right? And let's test to see if what we found is correct. Oh my gosh, it's perfect. Right? Thank you, Miss Margie. I appreciate the feedback. Right. So every time you work on these questions yourself, you can actually check to see if you're right. So you don't need necessarily the answers for all those questions. Where are they? Nope. I've lost them. Oh, here. You don't need all the answers for these because you can just plot them on Desmos. Easy money. Hopefully that was good, right? How do you go for a graph calculator? Ask Miss Maraji later. We'll probably do Locus again later on. Because there's another layer to Locus we haven't quite done. But 10 out of 10 from Hannah, awesome. Right? Is it really hot today? I opened the window a little bit, but it would be stinking hot otherwise. So good. Do we do Connect? No, Connect has been removed. Not removed. No schools do it anymore, essentially. If we did Connect, then we would teach all this stuff in Connect. Cool beans. Happy? Oh, do you do Connect in the graphics calculator? I honestly have no idea. I haven't looked into it. Ryan's happy. 5 stars from Kate Malone. Put a 5-star review on TripAdvisor. Cool. I'm gonna leave it there. That's gonna be us, guys. We're basically done. Now, no more live streams for a while. So just a heads up. Please, I highly recommend, or we can put on a bloody song if you want, Grumpy Bums. Here. It's not too loud, is it? So I highly recommend checking out the other videos or recapping, going over them, especially if you missed any. Miss Maraji is saying we can release assignment 3. Okay, that means they've got 2.5 to be working on, sir. That's a bit rough because we've got they've got their actual assignment that's worth stuff, their common assignment. I think we maybe, yeah, I'm seeing what I say we could leave it in our arsenal for potential potential extension to the lockdown, right? I'm sure you guys have been talking or hearing that a lot of people are suspecting that the lockdown will take longer than 4 weeks, right? It's 4 weeks at the moment, but they might extend it. I don't know anything about it, right? But I'm just saying, in the event, it's definitely possible that it goes for longer. We'll start streaming back here again probably, or we'll figure out a way to do something like this. But like Mr. Murray says, if in lockdown, calculus is to the rescue. Okay, Hannah's that is the most Hannah thing I've ever read. But no, it's not gonna be any more Nutshell Maths streams for the next little while. Um, but what I would love you guys to do is please, 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 whilst this is fresh in your brain, go look at the assignment, the common assignment for everyone, and find the locus question. Just do it today, right? Do the locus question today, and maybe some De Moivre's theorem questions too. Try 2 or 3 of them, and then have a break for the rest of the day because you've done an hour of hardcore maths. Okay. When I put answers to Cat assignment 2, I will do them and then put the answers up. Give me a couple of days. Right, I'll put them up soon. Right. Have you done all of them, Kate? Have you finished assignment 2? Almost all of it. Good. Gonna miss the streams? Yeah, me too a little bit, dude. Me too. I'm not gonna miss the prep though. It takes a long time to prep one of these good lessons, honestly. Yeah, okay, I'll put the answers up. What I could even do is next week sometime, maybe we do a midweek little live stream on Wednesday, and it can be like a AMA about assignment 2 for myself and Mr. Meraji's class. Would you guys find that helpful? So I'll do assignment 2 by the middle of next week, an AMA, like an Ask Me Anything. So I'll just have all the answers. I'll upload them beforehand, and then we can just do, sir, can you go through this question? Sir, can you go through this question? And I'll just do that for an hour. A question and answer. An AMA about the assignment. Numpty. Felix thinks that'll be good. Kate's pretty happy. And that might give you a deadline, right? Of like the assignment needs to be done by then. Okay, let's aim to do that. So let's go through, as long as Mr. Murad is reasonably happy with that. So we'll go through, that means I'll go through the assignment next week. Can we, next week Wednesday maybe, midweek? That's okay. Yeah. Next week Wednesday, live stream, an AMA about assignment 2. If you don't have access to assignment 2, i.e. you're not in myself or Mr. Meraji's class, just message someone who is. I think Abhishek, you're not, right? Go get your second cup of coffee, Matt. Awesome. Yeah, and then school starts the week after. Yeah, exactly, Kate. Or school starts the week after. Isn't there still one more week of thing? Oh, Abhi's in Meraji's. Oh, okay, all good. Yeah, Tina, I haven't looked at the God number question. I would imagine it's kind of like, remember the last assignment, that question 5, there was heaps of wording, but it was just like a rearranged question. I would imagine it's kind of like that. So just have a look at it, try rearrange it to make it easier. Hey, but thanks to everyone who's been tuning in, especially the regulars. Really appreciate it. Thanks for the follows, subs, donos, all that jazz. But yeah, I'll see you guys on Wednesday. And I'm gonna go play some video games while you guys do some maths. Have fun. Thanks for watching.